So we'll start without Pete.
I think that's a good plan.
So in Kafka, you're going to deal with records. You have a consumer record, which is the class that a consumer has, and a producer record, which is the class the producer has. Every record has a key and a value. You can have null values or null keys as well. The key and value are arbitrary. Kafka doesn't care about them except as a sequence of bytes. Your application probably doesn't want a sequence of bytes, so you need to have serializers and deserializers that are configured through properties to actually read the keys and write the keys. And the key serializer and the value serializer need not be the same thing. So your Kafka system is going to have producers, which create new data, consumers, which want to read the data, and then there's a broker in the middle. And the Kafka data is organized into topics. So whereas Deephaven might have a table, Kafka will have a topic. The broker is responsible for actually writing that data down and then sending an acknowledgement to the producer. You have a few choices as a producer about how you want your data acknowledged. So, excuse me, you can have it such that you just write your data and you don't care about any acknowledgments. You're just going to continue on and not worry about it. If the message is lost, the broker goes away, anything like that, you lose your data. You can have it set to 1 so that, you know, okay, at least one broker got my data. Or you can say all, in which case you are going to require the consensus of brokers to have the data written down and acknowledged.
Does that make sense to anyone?
It sounds like it uses TCP to basically send acknowledgement messages back and forth.
There's a protocol over TCP that the producers will send produce requests and get told, yes, you've produced this data and I've written it down. So your Kafka cluster typically has more than one broker, and there is, or in the past at least, there was an instance of Zookeeper, and Zookeeper is an Apache distributed system that would basically tell you where to go and who's alive for a particular topic.
Yeah, and so go ahead, Charles.
The 0, 1, and all are basically how much replication or durability you want. So if you go with 0, you know, it's kind of like YOLO, right? You send your data and maybe it's written, maybe it's not. You have no idea. If you say 1, you know your data is written in at least one place, but if I decide to vaporize that broker before replication takes place, maybe your data would disappear. If you say all, you know your data is written and it's going to stay there forever.
Yeah, but the downside is you get latencies while it ensures consistency.
Exactly. So depending on what your use case is, you're going to make different choices there. And when you get something written down to the broker, what your acknowledgement includes is an offset saying, okay, your record is located here within this particular topic and a partition. So,
yeah, and that kind of points out one of the things with Kafka, and it seems like one of the hardest things is configuring it properly, because it supports doing many different things, and you have to come up with the right recipe
Yeah, you need to know what your data is, what your use case is. I think most people who use Kafka also pay Confluent too for various extras, particularly the schema registry. So you have producers, they send the data to the broker. Consumers will subscribe to data from the broker. So you have topics, partitions, and then offsets. So each Kafka topic is divided into partitions, and this is something that you configure. The producer records either tell you what partition something belongs to, or there's you can configure a partitioner which will determine which partition, based on the key. So that way, if you have a particular key, it always lands in the same partition. Typically, that's just done by hashing. And as Kafka looks at things, the key is a sequence of bytes, which means your serializer better produce the same sequence of bytes for two equal values. Otherwise, you might have a bad time. So every partition has a total ordering of messages. Each message within the partition has an offset. That starts out very simple. Basically, it's in order. So you have a message, it takes up some number of bytes. So it's at an offset within a file, and that's where it is. And when you write it down, there's a log file. Kafka assigns it to an offset, and that offset determines the total order. If you have a single producer, then mostly the messages you write are going to be exactly in order. You can guarantee that by saying only one message is in flight. If you allow more than one message in flight, if you produce two messages and the first one fails, and then you get the second one written, and then you retry on that first one, they'll flip around. So between different producers, there's no guarantee of the order, but once it's set, it's going to be fixed. It's in the log, they have an offset, that's where they belong.
So Charles, can you compare these partitions to the Deephaven ones?
So Deephaven partitions have a single producer. You can't write data into the same partition from more than one place. In Kafka, you can. So if I have 7 partitions and I do hash on my key, and then I have 2 producers, you're equally likely to have data from either one of those producers in a partition. Kafka partitions are just integers. They're not free-form strings like they are in Deephaven. In our Kafka ingester, we have a one-to-one mapping of internal partition to a Kafka partition. On the enterprise side, you guys don't have a DIS and corresponding persistence, but that's how we do work on the enterprise side. The broker is what determines the order on a Kafka partition. On a Deephaven partition, it's determined by the producer on the log file. Nothing can ever be changed or intermixed. That's mostly the difference, that Kafka partitions, because you have the broker, it's determining the order. And in some ways, you can think about that like the log aggregator service on Deephaven Enterprise, but the log aggregator service is, I don't think you have that in Community Core. And also, it doesn't have the same kind of redundancy that a Kafka broker would have.
Is there an advantage to having a single producer to Deephaven's approach with a single producer per partition versus Kafka approach with multiple producers per partition, or possibly multiple?
Well, Kafka's approach means you stripe your workload evenly. Deephaven's approach means that there's no concurrency concerns between the independent producers to a large extent.
And can you discuss the offsets a little more?
Yeah, so just think about it. You have a really big file. You start at offset 0. You write a 7-byte message or a 100-byte message. Your first message has an offset of 0. The next message you write is going to have an offset of 100 if you wrote 100 bytes. And then you write 50 bytes. The third message will have an offset of 150. That's how it starts out. It doesn't stay that way because there's compaction and cleaning, but that's how it'll begin with. And each message has an offset that is permanent.
Yeah, and so when you start up a connection, you can tell it what offset to start at.
Yeah, a consumer can say, so producers always append. A consumer can say, start at the beginning, start at a specific offset, or start at the end. So how a Deephaven consumer works is we write down the last offset that we replicated. Otherwise, we start from the beginning if we haven't written anything down yet. We write down the messages and the offset atomically. That way, when we restart, we can resume exactly from where we left off. There's auto commit, which is a common way of using Kafka so that consumers will just, after they've gotten a message, will write back that message to Kafka itself so that when a particular consumer resumes, it will have a sequence of messages. But if you're trying to do something like replication and you're just depending on auto commit, it's not feasible to ensure that those things are in sync. Okay. Keep hitting the wrong key. So this is a diagram I ripped off from the Kafka book. So you see that a producer record has a topic, partition, key, and value. It's serialized, it's partitioned. You send a batch of records to the broker to a particular partition. When it's successful, you get your metadata back, which is basically the offset.
Okay, Charles, can we go back to that just for 1 second? Yeah. I just want to point out that the serializer here is not just a straight Java serializer. This is a user-specified serializer to turn your object into bytes.
Yes.
And there are many different flavors for doing this.
Yeah, I'll talk about them a little bit more, but there's probably 3 common flavors, and then you can do it, roll your own as well. You just specify a Java class that implements a particular interface, which is basically, here's an object, give me a byte buffer. Here's a byte buffer, give me an object. So when you have consumers, they are part of a consumer group. So the consumer group is meant to act in concert. And if you have 4 consumers in a consumer group, you need to have at least 4 partitions for anything to make sense, because each partition is processed by 1 consumer. The consumer group is just a name, like, you could have Chuck, Chaz, and Charlie as your consumer groups, and each one of them is gonna read the data and acknowledge it. If any of the consumers within the consumer group acknowledge the data, then you're not going to get that data to any of the other consumers in the consumer group. You can add consumers and remove consumers, and there's a rebalancing process that can take place. When you do that, you need to be careful about processing duplicate messages. And like we talked about before, you can start at the beginning, the end, or a particular offset. It's very common to use auto commit so that once you've gotten the message from Kafka, you say, yeah, I got it, and then you'll process it. Now, if you crash before actually processing it, then auto commit is problematic.
So Charles, is this something that just lives on the client side where
No.
it's up to their configuration, or is this something that we have to worry about from the connecting end side?
From the client, you worry about your consumer group and how many consumers you're starting. You don't have to worry about, if you're using auto commit and you're resuming, you don't have to write down your offsets. Or even if you're not using auto commit, but you're committing to the broker, I think you can do it by hand. Then Kafka just magically does that. There's also some magic about rebalance and things, and some configuration that you can specify. But when you start your consumers, based on the number of consumers you have in your group and the balancing, it will assign a partition to those consumers. And you shouldn't need to worry about how many partitions there are, how many you're actually processing, but you do need to configure the number of partitions such that there's enough of them for the consumers to process. And you want to make sure that they're somewhat even, right? You don't want partition 0 to be 90% of the data, and then 1, 2, and 3 to be 3% each. So we've talked about offsets and say, hey, they're just the offset in the file. That's not really true, because Kafka only appends to a topic, and if you just do that forever, you grow without bound. You can have a lot of values for a given key. Let's say you were using Kafka to store market data or positions. You might have a key like trading group and security, and you only care about the most recent position for that group. In that case, what you can do on a schedule, based on how big it is, how old things are, there's choices there. You can read a section of the log and then rewrite only the most recent value for each of the keys. And then older values are discarded. The offsets are still preserved. So the record that was at offset 42 stays at offset 42, even if records before it were deleted. And there's an indexing structure that Kafka has on disk to make that actually work.
Okay, so I think people should ask questions on this because, it's a fundamental concept. Or is this obvious?
It's not obvious.
Yeah, I wouldn't say it's obvious. I just don't know what specific questions to ask just yet. if I, seeing an example of this in action might help me.
Yeah, so, Charles can fill in the details I don't know, but imagine you have a giant file and you have this thing up and running for days or years and stuff just keeps dumping in there.
Yeah.
At some point you want to say, well, I don't really care about everything. And so you have to start dealing with old data. And that's what the compaction process is doing.
Yes.
That's not getting rid of old data. It's doing
It is getting rid of data, right? So it is actually, you read the data, but you only rewrite the latest record for each key.
Sure.
Yeah. So you take
So
data
this is the
older
book, by the way, that I stole my pictures from.
The book you recommend us browsing before we write the Kafka documentation, or?
It depends on what you're doing. I mean, I often prefer to read a book if I'm just trying to learn about the topic. If I'm, I can read 300 pages cover to cover and have an overview. If I'm actually trying to do something, then I would probably just read the documentation.
And with Kafka, at least in my experience, I've yet to find a fantastic book. Maybe Charles has one.
I mean, this is the O'Reilly.
Yeah, that may have been one of the ones I read.
This one.
Yeah.
I don't know if there's a new edition, but
yeah.
Well, the Confluent site has that. Like you can trade your personal information for a free copy. You can. I guess the question I have is about context. Like, if I've used Kafka for as a service bus, right? Mm-hmm. Like, I want kind of guaranteed delivery, and I want sort of the leadership election that it does, and I want to know, I want to distribute. I want to have someone. Like for me, the producers would be like, "Oh, I'm requesting this work. Here's some work you need to do," and the consumers would be like, "Oh, well, we do work. Who will do it, and how do we know we've done it, and can we communicate reliably between people who are producing requests for work and people who are satisfying those work requests?" Right?
Yeah.
And I think it's a pretty typical application. I'm not really sure how I would fit Kafka to Deephaven. Like, why are you Kafkaing?
Well, I mean, one example that we have customers who are publishing market data. So the actual customers using Kafka, I don't know of any. We have a prospect using Kafka, but we have actual customers using Solace, which is close enough. And they just use that as their message bus for everything. So their order state, their latest prices, all that kind of stuff. I think actually Snowcone uses Kafka, but I don't know that they have Kafka hooked to Deephaven. And it's the same kind of stuff: order updates, market data, publishing other derived pricing information, that kind of.
Yeah. So Mike, just imagine mapping a topic to a table.
Yeah, and that's what we do. We import a topic as a partition and just replicate the data, whatever deserialized object that we're getting, we turn it into columns using a builder.
Okay. So then the producers are throwing you like records, or maybe they're even sending. I mean, maybe each message is multiple records. Like I guess you could.
It depends. We have some cases where so this is not this. There's compaction in here somewhere. Where the hell is the index?
So it ends up just being like a layer for data collection and data movement. I mean, people can publish facts and they show up as records, and the messages are processed in the Kafka way.
Yeah.
Some consumer eats them and gets them stuck in a Deephaven, and then now that they're in Deephaven, we can go query them and manipulate them and graph them and report them and dashboard them.
Yeah.
Okay. Sold.
Yep. So anyway, this is, if you look at it, you have a log for compaction split into some portions. The clean portion doesn't have offsets with duplicate keys. The dirty portion has every offset, but you're going to have duplicate keys. And there's mapping so that you can basically seek to the right place within the log.
Yes, you can imagine like compacting nightly data where you just get the summary and the last value every night or something.
Yeah, there's usually it's based on the size and time is how it would do it. It's a process configured on the broker that's just magic.
Just going back a couple minutes, I honestly got a cold sweat when Mike said, I don't understand why one would marry Kafka to Deephaven, because fundamentally, if it feels like the reason to do that is fringe and not central, I think we're dead in the water. And I kind of mean that. Kafka's the dominant real-time message bus, and real-time capabilities is our leading story. We have other stories, but that's the leading story because it can be said quickly and is not totally consumed by somebody else yet, or by 20 competitors. It's consumed by a few. So I think we want to be focused on, if Kafka streams exist, there are other ways to process them. What value does doing it via Deephaven add relative to those other alternatives, including, by the way, congruence, Kafka, or KSQL, KDB, right? Confluence, sorry.
Yeah, so my take on that is if you've persisted that, or even if you haven't, having a Deephaven table is a very powerful analytical tool. So I would say that's why you marry. It's also important to point out that we don't have a Kafka integration on the other direction on the enterprise side, but we do, for example, with Solace, in that we take Deephaven tables and we spit them out so that our customers' other systems can process, for example, JSON messages that tell their OMS to stop trading for a particular group in security.
Right. And obviously we need to support both sides of that. But again, we need to drive home what you summarized in a sentence. We don't need to do it here, but it needs to be, it's, 3 of our top 10 paragraphs, if you were to give it, need to be more detail around the sentence of the Deephaven table abstraction is a powerful one, and the fact that it can be fed by Kafka gives you these abilities and those abilities that don't exist if you were working with other alternatives of Kafka stream process.
Yeah, I think the way to think about it is that Kafka deals with all of the data routing and things like that, so you can just push data there. And with Deephaven, you can pull that data and then do complex analytics on it.
Yep, and I'm totally on board with that. I think KSQL would make an argument, we do that. And I'm sure Spark would make an argument, we do that. And so we're going to have to at some point get in the weeds and say, yeah, but they can't do this thing or that thing, or they're worse at this thing or that thing, or they're harder at this thing or that thing.
Yes. But to do that, we have to invest the time to actually try to do things on those platforms.
Yeah, 100%. Yep.
All right. Key and value serialization. There's simple serializers for primitives, which in Kafka means double integer long string, arrays of bytes or byte buffers. JSON is a common payload format, as is Avro. Avro is a binary format with a schema, and you either get out what's called a generic record, so think hash map, or you get out plain old Java objects if you compile the deserializer, and that's going to be quicker than using a map that is not specific to your type. Managing schemas is difficult, so this is typically used with a schema registry that's a commercial bit of this from Confluent. And your key and values can have different serializers. They're not necessarily the same thing. They're handled independently.
So can you talk about serialization versioning for these guys?
That's why you would use the schema registry. So it will have all the versions of a particular schema and know what's forward and backwards compatible, and be able to give you a deserializer. Typically is where that matters most. A deserializer that'll read the old version for you. There's a lot.
No, it's there's just a lot of customization. I'm trying to remember what you can do where, especially when he talks about it's more important for deserializers versus serializers.
So that is.
If you think about that, serializers just write it, move on. The deserializers can be used on old data.
Yeah. So, and you don't want to necessarily restart your topic. You don't want to have to update everybody at once. So there's reasons this thing exists in a deployed system. Schema versioning is certainly a painful process in Deephaven. Confluent tries to make it less painful, but you can't ever necessarily make it pain-free. So I posted a link in general about that.
Can you mention a little more on Avro, since that's...
Yeah, so Avro is just a row-oriented Apache serialization format. And you have a schema window. So you have a schema, something like this.
Can you zoom in?
Maybe.
We could stand next to the TV also, I guess. That doesn't help either.
These are like pixels.
Yeah, you're below the resolution of our screen here.
I'm trying to figure out how to change the font size.
I think there's if you're in IntelliJ, I think there's a presenting mode.
Oh. Enter presentation mode. Is that better?
Got a little bit bigger.
A little bit.
I can read it.
I think we can make it out.
Oh, bigger again.
I think we're good, Charles. We can at least take out the words.
Yeah, I don't know how to make my font giant, but it's a JSON thing. It says, hey, you have a number. It's an int, and it's the number of the player. And you can have things like, what's the last name of the player? You can also have not just strings or ints, but you can have something that's a long, but then has a logical type that's in millis or micros, for example. And that allows the other end of this to interpret it properly. And then let's see. So you end up with a generic record, and that basically has keys that you can get a value from the generic record after you've deserialized it, and you get an object back. But if you compile these, do I have?
So the generic record will just take the Avro file and then just use within the file to construct the object.
Yes.
Okay, so it's doing a lot of work.
That's right. When you consume a Kafka record, you get a consumer record. It has the partition and the offset are just part of it. You potentially have a timestamp, and then there is the key. And Kafka does the deserialization for you, so you just have a Java object that's a generic record. And then you can go through it and say, all right, my key might be null, but if it's not null, I can get a particular field out of it and then do something useful with it. Same thing with your value. The alternative is that you actually compile these things down to Java classes, and then we can, at least in enterprise, we'll compile a thing to take your class and
Okay, so I'll let you look confused. So you can take the Avro file and run it through something, and it will spit out a Java class with all of the serializers in it. So it doesn't have to do like this internal meta stuff. It just looks and feels like a Java object because it is.
Trying to see if I have an example.
So do users ever need to be concerned with this at all?
Depends on what.
It depends on what you're doing.
So the person putting the data into Kafka definitely cares. The person pulling it out and putting it into one of our tables also cares.
Sure.
Does that make sense?
Yeah, I don't have.
Yeah, so in Kafka are stored just chunks of bytes. And so for those bytes to be useful, you have to turn them into objects. Sure. So you can either do these generic objects or
Avro does.
Well, Avro, you can do just the generic ones where it's slow. It's easy to write because you're not having to generate code, but it's slow with a lot of lookups and things. Or you can directly convert the interpreting part into Java code. So it gets the blob of bytes and it's like, oh, well, this is obviously whatever, and it just goes with it.
Yeah, there's Avro creates, instead of a generic record, you get a specific record, and it's going to have, fields for, what was in your schema that,
And I have an example of this that I wrote, which if somebody tags me in the channel, then I'll send a link to it.
Yeah, I definitely be interested in looking at that. It's a long way to go.
So right here, this is a specific record. So you're saying set content or set date time, right? If this were a generic record, you would have to say set content hello world, set date time, instant now to string. With the, on the consumer, the same kind of thing. You're getting content, you're getting date time, versus here, they're doing record value get content, record value get date time. And you're going to be more efficient with the specific record than the general record. All right. That's what I have.
All right, so any questions for Charles, since this is something we'll have to support?
Well, as far as, we want to, I think we've covered why you would want to use Deephaven with it, because the analytics are great, and you can, it seems like if we want to make the sales pitch that you want to marry Kafka with Deephaven, we would have to give a few different use cases where we can show that we've got this, Kafka thing set up that has a few producers and the consumers just write the table data to Deephaven. Would it be advantageous for us to write different, a few of these use cases, some of which need to write extremely specific things in a very fast manner? We can show that we can do this quickly and then do the analytics quickly and efficiently in Deephaven. And then on the other side of the spectrum, we have, something that we don't care as much about the speed with. So we can just write a few generic records and use Avro to do the unpacking. And who cares about the speed, because we're only getting a new record every 15 seconds or something.
Yeah, I mean, you could do that. It's also worth pointing out, it's not just our analytics, but, it's an analytics together with UI that you're not writing from scratch.
Yeah, and on the other side of it, the exhaust from the queries should also be able to go into Kafka as streams that could be used in other Kafka applications.
Okay, so like taking the output of a Deephaven analytics, turning that into a Kafka producer and then sending that off elsewhere for other things to work with.
Yeah.
Okay.
So if I'm like a user on the OSS side and I want to, like, there's a website that I can find ticking, geological data or whatever it is, do I now have to learn Kafka to go in and be able to use that data real time in Deephaven?
So I think there are different parts of Kafka to learn. One is like the setup and configuration of the actual Kafka stuff, which is hard and very specialized. You then have I'm just a user of Kafka. And in that case, you kind of just pointed at the Kafka cluster with an address or whatever, and then say, this is the topic and this is the whatever, and then you get the data. So it should be easier at that point. Charles can tell me I'm wrong here.
No, I think setting up a Kafka cluster isn't crazy. You can also do it in the cloud. You don't need to set it up yourself. You can you can pay Confluent to do it for you. And then if you have a sample consumer application, you can adjust it to your needs. If you just wanted streaming data in Deephaven, it's not clear to me that you would wash it through Kafka, but you could. I don't know that you can now, given that, that's up to, you guys to decide what your community core product includes, what it doesn't, and what the best way to get data in is.
Yeah, let me interject here. So until we have support, well, until we have some traction, one, and two, we have a good data science offering. In my opinion, the dominant communities that we want to face are people that have Kafka streams and people that are unhappy with Spark. And so, hey, you have ticking data. If you have ticking data and you've never thought about how to put it on a bus, whatever, probably, you find Deephaven and then discover this thing called Kafka, which is really, really, which is 4 orders of magnitude more famous than us, but you didn't invest in. It's just unlikely, right? So it's like people have Kafka streams. We want to make it easy for them to get them into Deephaven and do things in Deephaven they couldn't do with KSQL primarily, right? So I don't know, is KSQL good at joining lots of Kafka streams? Is KSQL good at joining Kafka streams with Parquet? Is KSQL good at creating ticking dashboards? I don't know. We have to figure out some really obvious things we do well that KSQL doesn't do for somebody who already has Kafka streams. And then in regards to getting things in easily, I think there's two versions of that. One where the user kind of knows what they're doing, and the other where there's a platform and we just point at it and get stuff, right? And running platforms is Confluent makes all its money. So there must be a lot of them out there because they sold for $10 billion literally a couple days ago. And that's how.
Yeah, if you go to pretty much any conference, you'll find out that any larger size company has Kafka, just because it's an easy, consistent place for them to just.
In S1, they claim 200 paying customers. So you guys know open source as well as any.
Wow.
They must have 20,000 users.
Yeah, and if you guys want to just play with Kafka and the examples I set up, I have directions on starting a container and connecting to it, so you can actually, kind of touch and feel the administrative side also.
But I think we know essentially we've made a leap of faith that A, real-time data matters, B, there's not a great solution, and Deephaven, and C, Deephaven is the best solution out there. The biggest challenge to that point of view is going to be Kafka, and the second biggest challenge is going to be Spark and Databricks, and we know far too little about each of them. And this coming, in the next couple of weeks, we're going to sit down with a communications company that's going to help us shape our story, and they're going to ask very, very specific questions around this. In that, if we're going to tell a story to JJ before he had ever heard the word Deephaven, what gets his attention, and what makes him touch our, GitHub site and become a little sticky with us. And to me, how we interact with Kafka, there's just a natural bunching of an audience there. They care about real-time data. A lot of them know Java. Hey, maybe we should start there.
Well, Amanda and I went to the Databricks conference, and a lot of their pitch was, well, look at us, we're super cool. We have this data lake house that takes a data warehouse and a data lake and it combines them, and oh my God, we're the coolest thing ever. But they don't offer any, and their whole thing is that you have this big organization that you've got all these pieces of data here and here and here, and everybody's touching different things, and you want to centralize them so that these developer or these data scientists can talk to each other. And it sounds like that if we can make the pitch that, hey, you have all these, developers that make these really interesting, complex Kafka producers, and then your consumers are all the data scientists that aren't really working with one another. It sounds like Deephaven has an advantage in that field, especially over Databricks, because Databricks didn't talk about giving the analytics platform. They just had this giant centralized data lake house that, oh my God, it's so cool that everybody can grab data from the same spot, but it didn't actually offer all these, really easy to use.
So I think you're totally right. I take exception to one thing. We don't want to think we're facing only data scientists, right? There are people that build applications as well with data, and why it's a continuum. Why do we have to think of those two groups as different? The way companies really work is those people are on the same teams across the business. We're the answer. Like whatever they're, they should be able to use the same platform, and Deephaven's that platform, right? So yeah, getting access to a couple of Kafka streams from wherever and making them work in Deephaven, combining them with Parquet, combining them with, some in-memory source in, October 2021, in a really easy way is interesting. Hey, it would be great if the next thing we made easy is, Databricks did all the work, so now you have a Spark or you have a data lake. Sweet. Just point Deephaven to that data lake, and now at least all the warehouse part that's structured, you get all of these analytics, all these things that are super easy, all these user experiences out of the box, right?
And you make it easy for somebody that's already on that to use our stuff.
Right. We, unlike our history in enterprise, our present and future in community, as I understand it, is not that we want to be in the storage business or tell you how to do that stuff. Rather, there are going to be 4, 5, 7 dominant technologies for that, we think, right? Like, Parquet, Arrow, Flight, Kafka, maybe the Spark data lake, and ODBC, JDBC, something like that. And like, hey, great, you have all those set up. We're the higher stack that sits on top of it for your, your analytics and your application development and your dashboards and all the rest. And we're interoperable with all of that. We're not competing with it. And by the way, we're easy and powerful. If we can make that, we kind of rule the world. But obviously right now it's a bunch of hot air coming out of Pete Cotter's mouth, and it's probably far from the truth.
Well, no, I agree. I mean, again, if you can set up like a complex application taking data from all sorts of different sources and present it and say, hey, look, we feed it all into Deephaven. We've done all the work on the back end. Here's how we did it. Look at all this analytics we're doing super easily using these, diversified data streams. Your company might want to use this, or, your group might want to use this.
That's the pitch. I believe in it pretty heartily, but we have to convince other people of it now.
Yeah, and so anytime you guys see something that's, there are a lot of users, like the lake house or whatever that thing they're pitching is, that should be part of our discussion for future plan. And if we have something that, is harder to use than it should be, that makes it harder for someone to just flip the switch and just try it.
Mm-hmm.
Yeah, for what it's worth, this is obvious, and usually I hate it when people quote famous people, but it happens to be timely. And this morning in my LinkedIn feed, I happen to have gotten the headline that I'll paraphrase something like, from Steve Jobs, you start with the user experience and then you work backwards to the technology. Obviously, we have not really done that, either as a tech stack or as a company. But we are taking this moment in time to force ourselves to do that, right? Like,